Another new feature, adaptive execution plans. Adaptive execution plans, you adjust the code on the fly while it's actually running, which is, when you think about it, quite an amazing concept with limitations. So Oracle develops an execution plan, starts running the statement. During the run, it realizes there was some horrendous mistake and will change the plan on the fly. Now, this facility, by the way, is enabled by default, and some people don't like it, but we'll talk a bit more about that later on. The things that can change, join method, and that's the big one, the join method. It can also, in a parallel query environment, change distribution methods. If you've enabled star transformations, there's some effects on bitmap pruning. So it can't do everything, but it can make some quite significant changes. How does it work? I'll demonstrate it first, then return to the slide. What I'm going to do is force Oracle to make a mistake. I'm going to give it bad information. So the example I'm setting up, I'm setting the table stats to tell Oracle that scott.emp consists of one row in one block. And for completeness, I'll tell it that the department table is also one row in one block. So I'm deliberately setting up a problem here. And now we'll see what Oracle is going to do with this. Explain plan 4, select star from emp, natural join, dept. What execution plan does Oracle come up with? So standard SQL tuning. You or your developers are seeing, how is Oracle going to run my code? And Oracle has decided that it wants to join emp to dept using nested loops. It's going to scan emp to retrieve the department number and use the department number to do a lookup into dept, a loop. That's perfectly reasonable because Oracle thinks there's one row in emp. So we scan emp, get one row, therefore we scan that index once, therefore we retrieve from the table once. Pretty good. But what if that table did not have one row? What if it had 1,000,000 rows? This plan will be a disaster because we retrieve 1,000,000 rows from emp here. Therefore, we do 1,000,000 unique scans. Therefore, we do 1,000,000 row ID retrievals. And all those unique scans and row ID retrievals are single block reads. This plan will be a disaster if that estimate is wrong. If that estimate is way off, we should be using hash join. And Oracle has realized that. See that note? This is an adaptive plan. This tells you two things. Firstly, it tells you Oracle is a bit worried about this plan. Because of that, probably. But remember, if this were the real world, it would be a plan that printed on continuous stationery would go from one side of the room to the other. Yeah, this is just a very simple example. But that tells you Oracle is worried. And it then tells you that you or your developers must do this. Format adaptive. You must check out the adaptive information. So, format adaptive, we see something very different. So, when Oracle parsed the statements with my explain plan 4, it in fact developed two plans, one of which was the nested loop that it really wants to use. But look at that. We've now got extra lines. Hash join, statistics collector, full scan of dept. And they've got a hyphen there. And we see here, this is an adaptive plan. Rows marked hyphen are inactive. So this tells us that Oracle really wants to use nested loop, but it's aware that the efficiency of the nested loop is critically dependent on the accuracy of that estimate. So it's going to monitor it and see if there is only one row in emp. And if there are more than a certain threshold, it will switch from the nested loop plan to a hash join plan. And instead of doing index key retrievals, it will do a full scan instead. Asterisks just imply that there's a filter, and the filter at row 6 is indeed the join predicate. And we see the join predicates being pushed up to that one as well. There. Oracle now has a choice. It's got two plans pre-computed and stored in the cursor. Statistics collectors will let it switch between them if certain thresholds are crossed. Well, let's see what actually happens when I run that statement. Let's just see. So far, I've only been working from explain plan. Well, I'm actually going to run it. So I'll run the statements, and I'm going to use the gather plan statistics hint again to make sure I get full information gathered. So Oracle expects that statement to return one row. I actually run it, and oh no, disaster! There were 14. The estimates were wrong. Well, what actually happened? What actually happened when I ran that statement? It actually did a hash join. So it did not do what explain plan said. Remember, explain plan said nested loop. In fact, when I ran the code, we got a hash join. And we see there, this is an adaptive plan. So let us see the full story. I'll run that. And I'll say how can I do that? Yes, the SQL ID and the child number, and then the format, adaptive. So the full story of what actually happened. At runtime, Oracle, see the hyphens, deactivated the nested loop and activated the hash join and the scan. Right. Because the statistics collector told it that even though there wasn't one row, there were more than that. So somewhere between 1 row and 14 rows is the crossover for this little query, where a loop becomes inefficient and the hash join becomes better. So what's the big takeaway from this? Well, it should mean that you'll get better performance automatically following upgrade, particularly in a data warehouse, a query environment. But the other big takeaway is that your developers are going to have to completely change the way they tune, because even more so than with statistics feedback, you have no idea what is actually going to happen when you run your code. It may not be what you think it's going to be at all. And the final topic, these adaptive features. They aren't always good. They should be, but not always. The adaptive features are really SQL directives, statistics feedback, and adaptive plans. Remember, directives persist the results of statistics feedback to the data dictionary. And adaptive plans will get saved as well. These will all trigger the creation of directives. These 3 features will mean that as you run your software, performance will improve. Of course, you need to consider the effect of SQL plan baselining. Some of the improvements might be held back until the baselining mechanism decides to permit them. But the end result is, as time goes by, these features should mean that performance improves. However, in a minority of cases, they cause major problems. Often because of the dynamic sampling that can be triggered. Well, in release 12.1, you have these parameters. You've got optimizer adaptive features defaulting to true, and adaptive reporting only defaulting to false. If you reverse these are the default values. If you reverse the settings, you'll disable everything we've looked at so far today, but you will be able to get reports about what the adaptive features would have done. In release 12.2, these parameters are basically deprecated and replaced with these. You have much finer control. So in 12.1, it's all or nothing. Adaptive features, true or false. In release 12, the adaptive plans are by default enabled. The adaptive statistics and directives are by default disabled. Oracle's assumption from several years of experience of release 12.1 is that adaptive plans as a general rule are a good thing, but adaptive statistics can frequently cause problems and may need to be controlled. But you don't get this level of control in 12.1.